Have you ever wondered what would happen if a nuclear bomb went off in your city? It's a terrifying thought, but understanding the scale of these weapons is crucial to appreciating why we must never use them again. Today, we're going on a journey to visualize the unimaginable, comparing different nuclear explosions and their potential impact on our world. Let's start with a historical baseline. Little boy, the bomb dropped on Hiroshima in 1945. This was a 15-kiloton bomb. A kiloton is the explosive equivalent of 1,000 tons of TNT. Imagine a freight train over a mile long, packed solid with TNT. That's 1 kiloton. So, little boy was like 15 of those trains exploding at once. The immediate blast destroyed everything within a 1-mile radius, and its heat flash ignited fires much further out. The total devastation was immense, a scar on human history. Now, let's scale that up. What if we took that same 15-kiloton bomb and detonated it over the heart of a modern metropolis, say, downtown Manhattan? The initial fireball would be about 600 feet wide, hotter than the surface of the sun. Everything within a half-mile radius, from the Empire State Building to Times Square, would be instantly vaporized. The blast wave would flatten most buildings within a 1-mile radius. That's a huge area, covering much of Midtown. The heat from the explosion would cause third-degree burns to anyone exposed within nearly 2 miles. The destructive power is staggering, and this is considered a small tactical nuke by today's standards. But humanity didn't stop there. During the Cold War, the race was on to build bigger and bigger bombs. Let's look at the W-87 warhead, a common part of the U.S. arsenal. It has a yield of 300 kilotons. That's 20 times more powerful than the Hiroshima bomb. If this were to detonate over central London, the fireball itself would engulf an area from Buckingham Palace to the London Eye. The immediate blast zone, where even reinforced concrete structures would be destroyed, would stretch for over a mile, obliterating areas like Westminster and Soho. Severe blast damage would extend for miles, shattering windows as far as the outer boroughs. The scale is almost impossible to comprehend. Let's keep going. China's arsenal includes weapons estimated to be in the megaton range. A megaton is 1,000 kilotons, or 1 million tons of TNT. Let's take a hypothetical 1 megaton bomb and place it over the center of Beijing. The fireball would be over a mile wide, instantly erasing the Forbidden City and Tiananmen Square. The air blast would level buildings for 3 to 5 miles in every direction, a zone of near total destruction covering a vast portion of the city's core. The thermal radiation would cause severe burns up to 8 miles away. The fallout, a deadly cloud of radioactive dust, would drift on the wind for hundreds of miles, contaminating land, water, and life for years, even decades. So far, we've only been talking about single warheads. Modern intercontinental ballistic missiles, or ICBMs, often carry multiple warheads, each capable of hitting a separate target. This is called a MIRV, or Multiple Independently Targetable Reentry Vehicle. Imagine a single missile releasing 10 W-87 warheads over a region. The result wouldn't be one explosion, but 10, each 20 times the size of Hiroshima's, creating overlapping zones of destruction that would make survival virtually impossible. This is the reality of modern nuclear strategy, not just city killing, but nation-ending potential. Now, for the king of them all, the largest nuclear weapon ever detonated, the Tsar Bomba. Tested by the Soviet Union in 1961, it had a yield of 50 megatons. That's over 3,000 times more powerful than the Hiroshima bomb. It was a demonstration of terrifying power. The test was conducted in a remote Arctic island, but its effects were global. The fireball was 5 miles wide. The mushroom cloud reached an altitude 7 times higher than Mount Everest, punching into the mesosphere. The flash of the explosion was visible from over 600 miles away. The shockwave circled the Earth 3 times. What if the Tsar Bomba was detonated over a major population center, like Paris? It's a horrifying scenario to even contemplate. The fireball would annihilate the entire city center. The blast wave would cause complete destruction for 20 miles in every direction. That's an area covering the entire city of Paris and its suburbs. The heat would cause third-degree burns over 60 miles away. People in London, over 200 miles away, could suffer from temporary blindness if they looked at the flash. The seismic shock would be felt across Europe. The fallout would be catastrophic, blanketing the continent in a radioactive plume. This isn't a weapon of war. It's a weapon of planetary annihilation. And, believe it or not, the Tsar Bomba was actually scaled down. The original design was for a 100 megaton bomb. The Soviets feared the fallout would be too severe, even for their own territory, so they reduced the yield. A 100 megaton weapon is beyond comprehension. The sheer energy release would be comparable to major geological events. So why do these weapons exist? The theory is deterrence. The idea that the threat of mutually assured destruction, or MAD, keeps the peace. If one country launches a nuke, the other will retaliate, and both will be destroyed. It's a fragile balance, a standoff held by the most destructive tools ever created by humankind. But accidents happen. Miscalculations are made. Tensions rise. The existence of these weapons is a constant low-level threat to all of humanity. It's why international treaties and disarmament efforts are so incredibly important. Visualizing the power of these weapons isn't about fear-mongering. It's about education. It's about understanding the stakes. From the 15 kilotons that leveled Hiroshima to the 50 megatons that shook the planet, the story of nuclear weapons is one of escalating power and escalating risk. When we see these animations and compare these blast radii on maps of our own cities, it becomes personal. It's not just an abstract number anymore. It's our homes, our landmarks, our lives. The knowledge of how to build these weapons can't be uninvented. But the choice to build them, to maintain them, and to use them is a choice we make every day. By understanding their true power, we can better advocate for a world where that choice is always no. A world where these terrifying visualizations remain just that, simulations, and never a reality. Thanks for watching. If you found this exploration eye-opening, please consider subscribing and sharing this video. The more people understand the true scale of nuclear weapons, the better our chances are for a peaceful future. Stay curious and stay safe.